Okay, so buckle up, because today we are diving deep into Windows internals. We're talking about the core, the nitty-gritty, all thanks to Mark Russinovich and his awesome book. You ever wonder what's going on under the hood of your computer? Well, we're about to find out.
Yeah, it's easy to just, take it for granted. I mean, click an icon, something happens, like magic, right?
Totally.
But the truth is, it's a whole symphony of, system mechanisms backstage making that magic show work.
Yeah, today we're getting that backstage pass. So where do we even start with something as massive as an operating system?
Well, like any complex system, right? It's understanding the building blocks.
Mhm.
And in the world of Windows, we're talking about system mechanisms. Think of them as the fundamental processes that make everything else tick.
Okay, give me an example. What's a system mechanism that really impacts, my everyday experience using a computer?
Have you ever, slammed your hand on the keyboard because your computer just totally froze?
Oh, who hasn't?
Right. Chances are it was these little things called interrupt request levels that saved the day, or IRQLs for short.
IRQLs. Okay, now you're just using acronyms. What are those?
So picture this, right? Your computer is juggling like a zillion things at once.
Always.
Always. And each of those tasks, from running your web browser to reading data off your hard drive, sends an interrupt request to the processor. It's basically saying, hey, I need some attention over here.
It's like all those notification badges on our phones,
Yeah.
just vying for attention.
Exactly. Now, these IRQLs, they act like a priority system for all those requests. They make sure that the super important stuff, like managing memory or talking to hardware, that always comes first.
So even though it seems like our computers are doing a million things at once, there's actually a really strict order to how those tasks are handled behind the scenes.
100%. Without IRQLs, it would be utter chaos. You could be writing an email, and suddenly your computer decides that reading a single byte of data from a download is more important.
Mhm.
Everything just freezes.
Oh, that's a terrifying thought. So IRQLs, they're like the unsung heroes, making sure our digital lives don't fall apart.
Exactly. They're like the conductors of an orchestra, making sure everything runs in sync.
Love that analogy. So we've got IRQLs. What's another one of these core system mechanisms we should know about?
All right, let's talk about kernel mode versus user mode. See, Windows, it's not just one big program, right? It's got these different levels of privilege, kind of like security clearances.
Okay, so is kernel mode like the VIP section?
More like the control room, right? It's where all the core functions live.
Mhm.
Managing memory, controlling hardware, the big boss, basically.
And user mode is where, my apps hang out.
Spot on. Browsers, games, all that stuff, it runs in user mode. It's more restricted, which is a good thing, believe it or not.
How so?
Well, this separation, it prevents a rogue application from messing up your entire system. It's a security thing.
Ah, so it's like a set of circuit breakers.
Exactly. You got it.
Smart. Now, I'm guessing there are times when something I'm doing, like in user mode, needs to access something in kernel mode, like if I need to save a file or something.
Right. And that's where system calls come into play. It's like requesting permission to enter the control room,
And I bet Windows is very, very careful about who it lets in.
You betcha. There's a whole security protocol to make sure only the right programs with the right credentials get access. It's tight.
Okay, that makes sense. So we've got interrupt handlers keeping things smooth, and we've got security guards at the control room door. What else is going on behind the scenes?
Let's not forget the ones actually doing all the heavy lifting. Dispatcher objects. They're the real workhorses.
Dispatcher objects. Is that some kind of digital train station?
Not quite a train station, but okay.
Okay.
Picture a busy intersection, right? Cars from all directions. Now, replace those cars with threads.
Threads, like multiple threads within a single program.
Exactly. Each one is like a separate worker within that program.
Mhm.
And they need to coordinate, right? Avoid collisions. Dispatcher objects to make sure that happens.
They're like traffic signals for threads.
You got it. Things like events, mutexes, semaphores. They control access to shared resources, so everything plays nice.
Can you give me a real world example?
Sure. Say you're editing a massive image,
Sure.
right? And at the same time, you're saving a huge file.
Mhm.
Both of those are using multiple threads. Now, without dispatcher objects, those threads could end up fighting over the same resources, and bam, you've got data corruption, crashes, the whole 9 yards.
So the dispatcher objects, they're like, hold on, Photoshop, you had the CPU last, File Explorer, it's your turn.
Exactly. They make sure everyone gets what they need when they need it. No fights, no crashes.
That's incredible. It's like air traffic control, but inside my computer.
It's happening every millisecond. Amazing, right?
My mind is blown. Okay, this is already a lot. What other system mechanisms are we diving into?
Let's step into the world of science fiction for a second. We got to talk about the Windows hypervisor.
Okay, you had me at science fiction. Hit me.
All right, remember those movies where they're like running multiple virtual realities on a single computer?
Oh, yeah.
The hypervisor makes that possible, kind of.
Wait, are we talking virtualization, like running multiple operating systems on one machine?
You got it. Windows hypervisor, it's like a virtual world builder. You can create and run virtual machines, each with their own operating system, apps, the whole shebang.
That is seriously powerful. But how does that even work? Like, how can one computer handle that much?
So think of the hypervisor as like a resource manager. It doles out portions of the CPU, memory, everything to each virtual machine. Basically tricks those VMs into thinking they have their own dedicated hardware.
It's creating an illusion, right?
Exactly. And the best part,
Yeah.
these virtual machines, they're totally isolated. One could be running Windows 11, another one Linux, even an old Windows XP, all on the same computer. Seamless.
Okay, that's seriously cool. What can you even use that for, though?
Oh, tons of stuff. Developers use it to test software. Businesses run old programs that aren't compatible anymore. Heck, you could even try a new operating system without messing up your main one. It's wild.
So it's like having a whole computer lab in your laptop.
Precisely. The possibilities are pretty much endless.
This is already more than my brain can handle. Okay, before we move on to the next mind-blowing thing about Windows, I need a minute.
Take your time. We've got a lot more ground to cover.
Okay, I think I've had enough processing time for now. We've established that Windows, it's a lot more than just clicking icons, like those IRQLs, the hypervisor, that's some next level stuff. But what about the actual programs we use? How does Windows handle running all that?
That's where we get into the world of processes and threads. They're the real deal, the ones doing all the work.
Okay, so if we're thinking about this like a city, are processes like the buildings?
Perfect analogy. Every time you open a program, like your web browser or even just Notepad, Windows creates a process for it. Think of it as a container, keeps everything separate and organized.
So each program gets its own little space, its own sandbox, which is probably why if one thing crashes, it doesn't take the whole system down, right?
Exactly. Isolation is key. Now, within each of these processes, you've got threads. Those are like the actual workers inside those buildings.
So if I'm typing in Word and it's auto-saving at the same time, those are different threads.
You got it. And managing all those threads, making sure they have what they need to do their jobs, that's where thread scheduling comes in. And that's when things get really interesting.
Thread scheduling. Okay, now you're just using big words to sound smart. Break it down for me.
All right. Imagine you have one processor core. That's like having one worker who can only do one thing at a time.
Okay, I can picture that.
Now throw a million tasks at that worker all at once. Thread scheduling, it's like the art of managing that worker's time so well that it looks like you're doing everything at the same time.
It's like when I try to multitask, but Windows is way better at it than I am.
Way better. Windows has this algorithm, right? And it switches the processor between different threads super fast, giving each one a tiny slice of time. We're talking milliseconds here.
So even though it seems like my computer is doing a million things at once, it's actually just really, really fast at switching between them.
You're getting it. It's so fast you don't even notice. It's like magic, but, computer magic.
Okay, that makes so much more sense. I always wondered how it could be downloading, playing music, and running a game all without, like, melting.
And hold on, it gets even cooler. Remember we talked about multi-core processors?
Yeah, like having multiple workers, right?
Right. With multi-core, Windows can take thread scheduling to a whole new level. It can actually run different threads on different cores at the same time. No switching needed.
Whoa, hold on. So now my computer can actually do multiple things simultaneously, for real.
For real. And it gets even more sophisticated. Windows can tell which threads are part of the same program, and it tries to keep them together on the same core. It's called processor affinity.
Okay, why bother doing that?
Because those threads, they often need to talk to each other, share data. Keeping them close reduces lag, makes everything smoother and faster. It's all about optimization, squeezing out every drop of performance.
This is way beyond anything I ever imagined was happening. This is like seriously impressive stuff.
And we're just scratching the surface. Windows is a deep, deep rabbit hole of fascinating stuff.
Okay, well, my curiosity is officially peaked. What other secrets are hiding in the depths of Windows?
Well, we've talked about how Windows makes things work, but what about keeping things safe? Let's talk about security.
All right, let's do it. What's stopping the bad guys from messing up our systems?
One of the big players is this thing called the Security Reference Monitor, or SRM. It's like the ultimate bouncer for your system. Nobody gets in without permission.
Okay, the SRM. I like the sound of that. How does it work?
So every time a program or a user tries to access something important, like a file, the hard drive, anything really, the SRM steps in.
Steps in how?
It checks their ID, basically.
Yeah.
It compares the request to a list of security rules, making sure they're allowed to do what they're trying to do.
It's like a security checkpoint, but for my computer.
Exactly. The SRM makes sure that only the good guys, the ones with the right permissions, can get to the important stuff. Without it, it'd be open season for malware and hackers.
Okay, that makes me feel a lot safer, especially these days.
Good. But the SRM, it's just one layer of protection. We've also got something called integrity levels.
Integrity levels. Okay, now you've got my attention. What are those all about?
Imagine, like, different security clearances within a company,
Yeah.
Interns get access to basic stuff, managers get more sensitive info, and then there's the executives with the top secret stuff.
Right, so it's about who's allowed to see what based on their level.
Exactly. Integrity levels work the same way in Windows. Objects and processes, they all have a level assigned to them. And those levels control what they can do and what they can interact with.
So something with a low level, like, say, a sketchy website I accidentally opened, it wouldn't be able to mess with important system files that have a higher level.
You got it. It's all about preventing accidental or intentional damage. Even if something shady gets through, it can't just go around messing with everything.
Smart. So we've got the SRM checking IDs, we've got these integrity levels, keeping things separated. What else does Windows have up its sleeve in terms of security?
All right, let's talk about something you've definitely seen before, even if you didn't realize what it was. User account control, or UAC.
Oh, UAC. You mean those annoying pop-ups that always ask me if I'm sure I want to do something?
Yep, those are the ones. As annoying as they can be, they're there for a good reason.
Okay, remind me again why these UAC prompts are so important.
Remember user mode and kernel mode.
Yeah, where my apps live and the control room of the system.
Right. So UAC is there to stop even admins like you from accidentally giving programs full access to the control room.
So even if I'm logged in as the administrator, if something tries to install itself without my permission, UAC will, like, stop it and ask me first.
Exactly. Think of it as a last line defense. It's making sure you really, really want to do something potentially risky.
Now that you put it that way, those UAC prompts don't seem so bad anymore. Better safe than sorry.
Exactly. A little annoyance is worth it to keep your system safe and sound.
Okay, so far we've covered IRQLs, the Windows hypervisor, processes and thread scheduling, and even delved into the world of Windows security. I gotta be honest, my head is spinning a little bit.
It's a lot to take in, for sure, but we're just getting started. Trust me, there's even more cool stuff to uncover.
Oh boy, I'm both excited and terrified at the same time.
But all right, what other intriguing features and tools does Windows have hidden up its sleeve? We've got a few more tricks up our sleeve, some real hidden gems that even experienced Windows users might not know about. And that, my friend, is what we'll explore next.
Welcome back to the deep dive. We've gone pretty deep so far, like IRQLs, the hypervisor, all that security stuff. Now you're saying there are even more hidden gems in Windows. I'm ready to find them.
Oh yeah, we've got more. Today, we're talking about those little known but super cool parts of Windows, the stuff that even, like, tech enthusiasts might not know about.
All right, I'm hooked. What's first?
Let's start with a security feature that's so tough it's got its own nickname, PatchGuard.
PatchGuard. Okay, that sounds serious.
Oh, it is. PatchGuard is like the secret service for the most vital part of your OS, the kernel. It's there to stop anything from messing with the kernel's code, like malware, exploits, anything that could take down your whole system.
So it's like a digital bodyguard, making sure nobody messes with the control center of my computer.
Exactly. And it's always on high alert. If PatchGuard even thinks something is trying to mess with the kernel, I'm talking a bad program, a buggy driver, even a user who means well but clicks the wrong thing, it shuts the system down. No questions asked.
Wow, no messing around. I'm starting to see why they call it PatchGuard. It sounds pretty hardcore.
It has to be. The kernel, that's the heart of your operating system. If that gets messed up, it's game over. PatchGuard makes sure that doesn't happen.
Okay, yeah, PatchGuard sounds like a good thing to have, even if I never actually see it in action. What other secrets are we uncovering today?
Let's talk about the Windows registry. You ever heard of this thing?
The registry. Like, shrouded in mystery, people talk about it, but nobody really seems to know what goes on in there.
Well, it's not as mysterious as people think. It's basically a massive database that holds every single setting for your operating system, your programs, even your user profile.
Wait, so everything, like my desktop background, the settings for my hardware, it's all in the registry.
All of it. It's the central hub that makes your Windows experience, well, yours.
I get why it's important, but I'll be honest, it's always seemed kind of intimidating, all those keys and values, and I don't even know what half that stuff means.
You and me both. It can get pretty complex. And honestly, unless you really know what you're doing, messing around in the registry is not a good idea.
Yeah.
One wrong move, and, well, let's just say it can cause some problems.
Yeah, that's what I thought. I think I'll stick to admiring it from a distance.
Probably a good call. Now, while we're on the topic, there's something else you should know about. Key control blocks, or KCBs.
KCBs. Okay, now that just sounds scary.
Yeah, they're not that bad.
Mm.
Remember we said the registry is like a giant database? Well, KCBs are like the index cards for that database.
Okay, so they help you find stuff. Like if Windows needs to look up a specific setting.
Exactly. Each key in the registry has a KCB that tells Windows everything it needs to know about that key, its structure, what's in it, even its security settings. They keep everything organized and running smoothly.
So it's like having a really, really well-organized library with a card for every single book.
That's a great way to put it. The registry might seem confusing, but the KCBs are there to make sure it all makes sense.
Okay, I'm starting to get it. So what's next on our deep dive into Windows?
Let's talk about a tool that system administrators love. Windows Management Instrumentation, or WMI.
WMI, that sounds pretty intense. What is it?
Imagine having this dashboard, right? It shows you everything about your system in real-time hardware performance, what software's installed, security logs, everything. That's WMI in a nutshell.
So it's like having X-ray vision into my computer.
Exactly. You can see everything that's going on, and you can even control some aspects of your system through WMI. It's a super powerful tool, especially for anyone managing a lot of computers.
Yeah, I can definitely see why IT people would love that.
Oh, they live and breathe WMI. And the cool thing is you don't have to be a programmer to use it. It's more accessible than you might think.
Good to know. All right, what's the last tool we're exploring today?
Let's finish up with something for the security buffs out there. Network Monitor. This one is really interesting.
Network Monitor. Okay, I'm intrigued. What does it do?
Imagine being able to listen in on the conversations happening between your computer and the internet.
Wait, really?
Well, kind of. Everything you do online, sending emails, browsing, streaming, it all involves sending data packets back and forth. Network Monitor lets you capture and analyze those packets so you can see exactly what's going on behind the scenes.
Wow, so you can see all the raw data. That sounds incredibly useful, especially if you're trying to figure out why something isn't working right.
Exactly. It's a lifesaver for network admins, security experts, anyone who wants to understand how their network is really behaving.
This entire deep dive has been amazing. We've covered so much ground, from the basics of how processes and threads work to hardcore security features and powerful tools. I had no idea there was so much going on behind the scenes of my computer.
It's pretty mind-blowing when you start to peel back the layers, isn't it? And the craziest part is, we've only just scratched the surface. There's always something new to discover with Windows. It's constantly evolving.
I'm both excited and a little overwhelmed by that thought. But honestly, I've learned so much today. It feels like the beginning of a very long and fascinating journey into the world of Windows.
That's what we like to hear. The best advice I can give you is stay curious, keep asking questions, and never stop exploring. You never know what you might find.
And that, my friends, wraps up another episode of The Deep Dive. We hope you've enjoyed this journey into the heart of Windows as much as we have. Until next time, keep exploring, keep learning, and keep diving deep.